Hello everyone, this is Dr. Zach. So today we are going to be working with our differential equations and solving them using separation of variables. Let's get started. Differential equations are often associated with slope fields. So when you draw your slope field, make certain that you draw very carefully, and it should look something like the one that I provided. For our first example, we're going to take the problem from your lesson preview and solve it. First, we're going to begin with separating the variables. We want y's on one side and x's on the other. Once you have your dy over x equals your 2dx, you can integrate. So when we integrate, we're going to have the natural log absolute value of y is equal to 2x plus c. Now, for this problem, we want to solve for y in order to get the general solution. The general solution, we do not know the c value. In order to do that, we're going to e both sides so that the e and natural log will cancel out. You're left with the absolute value of y equals e to the 2x plus c. Now that c is part of the exponent. So that when we rewrite it, you're going to get e to the 2x times e to the c. But e to the c is some arbitrary constant. So we're going to have the absolute value of y is equal to, let's just call it c rather than e to the c, and that's going to be multiplied by our e to the 2x. Now notice that says the absolute value of y equals c. So we don't know if that y is positive or negative, but because of the c in front, we can leave the absolute value off and be assured that the c will take on either the positive or negative value depending on where we're looking at our graph. Now, in this particular problem, we can find the particular solution given that x is 0 and y is -1. So we get -1 equals c e to the 0, or c is equal to -1. So our particular solution for this problem becomes y equals -e to the 2x. Now this was a differential equation because we had dy dx equals some sort of function. And a differential equation is always written in the form that the derivative is equal to some sort of function. If you have the second derivative, that's also considered a differential equation, and they can come in a the order of the differential equation is the order of the highest derivative. Now remember, your general solution still has the e, and if you have a particular solution, you can solve using an initial value. So for example 2, we're looking for a particular solution passing through our 0, -1. This is a differential equation of order 1 because it has a first derivative. In order to solve this, we're going to use separation of variables, which means we want all the y's on one side and we want all the x values on the other. Now, once we do that, we can integrate both sides of our problem and end up with a lovely answer. So the left side, oh, look at that. We have an arctan. I know you're surprised. So it's an arctan of y that's going to be equal to x cubed over 3 plus c. But then we want to solve for that y value. And when we do, we know that y is equal to the tangent of the quantity x cubed over 3 plus c. And that's your general solution. But specifically, we are looking for the equation running through 0, -1. So we're going to substitute. -1 equals the tangent of c. All right, so if that happens, we know that c must be equal to -pi/4 in order to make this true. So our particular solution is y equals the tangent of 1/3 x cubed minus our pi/4. So separation of variables is generally going to be a free response question on your AP exam. It does show up in the multiple choice, but pretty much free response all the way. So turn off the video, work on the questions 1, 2, and No, just 1 and 2. And once you finish those problems, you should look for the answers. So remember to use separation of variables. Then you're going to integrate both sides of your equation. Now, as you integrate this, notice you have the natural log of y on the left side and the natural log of the square root on the right side. So if we were to e both sides, we're going to get y equals e to the c times e to the natural log of that square root function. So this can be simplified, and when you simplify it, you're going to then be able to figure out the c value to write your particular equation. For question number 2, we're going to once again separate our variables. Recognize that we have a cotangent on the right side. So maybe you already know the integer of the cotangent. It's not a bad thing to know. And then for this one, we're looking for a general solution. You will not be able to solve for c. So y is the natural log sine of x plus c. Now, for example 3, you're going to look for the equation of a line that passes through 1, 3 and has the slope of y over x squared. So, since it's a slope, we're going to write the differential equation dy over dx equals y over x squared. Now separate your variables and integrate both sides of your equation. When we do that, we get the natural log absolute value of y is negative 1 over x plus c. E both sides of your equation, drop the c down in front, and you have, dun, 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 your general solution to the equation. But we're supposed to pass through 1, 3. So when we do that, we're going to let the y be 3 and x be 1. So we're going to have c e to the negative 1, or 3 over e to the negative 1 is my c value. Oh, so wait a minute. So c equals 3e. Do your substitution. You get y equals 3e times e to the negative 1x. And you might even want to take this and write this as 3e to the 1 minus 1 over x. So the next problem, your example 4, has a different set of directions. We have not dealt with verify problems. We're going to verify that y equals e to the 3x is a solution to the differential equation that I've given you, and that we have an initial condition of 0, 1. So when you verify a solution, you should start by confirming that initial condition. Does 1 equal e to the 3 times 0? So yes, we have verified the initial condition. Now, we're going to substitute the derivatives and second derivatives to see if the equation y double prime plus 2y prime minus 15y equals 0. So in order to do that, we need to find y double prime so that we can substitute. We know that y prime is 3e to the 3x, and y double prime is going to be 9e to the 3x. Substitute, we get 9e to the 3x plus 2 times 3e to the 3x minus 15 times y, which is e to the 3x, and that has to equal 0. So we do get 15e to the 3x minus 15e to the 3x equals 0, and we can make a statement that y equals e to the 3x is a solution. So for example 5, we are looking for an equation for the population of coyotes. And we're told that the rate of change, so that's dn dt, is going to be proportional. So we're going to put a k here to 650 minus n of t. Now that's 650 minus n of t needs to be separated from the dt. So we'll put 650 minus n equals k dt. All right, now it's time to integrate. We get negative natural log absolute value of 650 minus n must be equal to kt plus c. All right, so let's move the negative to the other side. Natural log absolute value of our 650 minus absolute value of n minus our n is negative kt plus c. All right, so we want to get n by itself. So as we think about doing that, remember in the reading we were given 2 points. We know that n at 0 is going to be equal to our 300. We also know that n2 is equal to 500. So those two values are going to help us find the k value and find the c value. All right, so let's start with the 0. When we think about our problem, substitute 0 in, we get the, oh, you know what? Let's rewrite it some more. We get 650 minus n is going to be equal to e, can't I drop that c in front now? Ce to the negative kt. And if I solve for n equals my ce to the negative kt minus 650 divided by negative is plus 650. Okay, let's throw in a 0 for my t value. So 300 equals c plus 650. So c must be negative 350. All right, we're getting somewhere now. So n equals our negative 350 e to the negative kt plus 650. But then we want to solve for n of 2 equals 500. So we know that 500 equals negative 350 e to the negative 2k plus 650. And when we solve for k, we're going to get a nice little 1/2 times the natural log of 3/7. So do the math and you will see it. So what do we know? We know that n is equal to negative 350 e to the 1/2 natural log 3/7 t plus 650. And specifically, I want to know what n at 3 is. So that means we need to substitute. This is a ridiculous problem, but we're going to get 551 coyotes. All right, so lots going on here. Make certain that you can do the necessary algebra. So now I want you to take some time, work on questions numbers 3 through 9. Once you feel good about your problem set, then come back and check your answers. All right, let's start with number 3. How'd you make out? Did you use separation of variables? Did you integrate? This one was a bit of a bear to integrate. You might have wanted to divide it up into 2 separate problems. Notice I even rewrote it so that the square root was in the denominator. Now think about why I did that. I'm always trying to make my integrals look like something I'm familiar with, and that helped me out. For question number 4, you once again had to do separation of variables and a lot of algebra to rewrite your problem. You can find your c value. Now for this one you can't solve for y. I solved for e to the x squared. I'm going to leave that one up to you how you choose to solve it. All right, now for question 5, that was a repeat. You should have been fine at number 5. And then there was 6, number 6. So notice after you did your separation of variables, you came down here and got a y squared. Now, if you take a square root, remember there are 2 solutions, a positive and a negative. This one, the c value, does not take on the positive or the negative, so you need a plus minus unless you're given further instructions. For number 7, you were to draw your slope field and then solve for your y. This one, the integration wasn't so bad, but you definitely needed to know how to use separation of variables. Number 8, this one had a trig function and log functions mixed together. Wasn't that kind of fun? I thought it was fun. So number 8, take a look at it. You're looking for that particular solution. Number 9, you are trying to verify your function. And when you verify your function, make certain you show all the steps so that you get your expression as you would expect. For today's lesson follow-up, make certain that you practice solving differential equations. This is a major part of your AP exam. So get some practice and make certain you're comfortable with it.